Okay, number 3 says, in a game of pool, the 1 kilogram cue ball with a velocity of 2 meters per second hits another 2 kilogram ball that was at rest. After the collision, the cue ball stays at rest. What is the velocity of the 2 kilogram ball? Okay, so the first thing you have to decide when you see a collision equation or collision problem is this elastic, meaning they bounce apart, or inelastic, where they stick together? What is this? Are they bouncing or are they sticking? Is this elastic or inelastic? It's elastic, right? Yeah, they're apart. One's at rest and the other one is moving afterwards. Okay, so we'll draw a quick diagram for this. So we've got cue ball 1, okay, which is 1 kilogram, and it's moving at 2 meters per second. You can copy this down while I'm doing it up here. Hits another 2 kilogram ball, so this one's 2 kilograms. That was at rest, so it's going 0 meters per second. And then afterwards, so the cue ball, the 1 kilogram ball, it says stays at rest, so this is going 0 meters per second now. What's the velocity of the second ball? So this one is moving. We don't know the velocity, okay, but we know that it's 2 kilograms. It says, what is the velocity of the 2 kilogram ball? Alright, so object 1 will go is 1 kilogram, and it's going at 2 meters per second, so I'll write this stuff down. 1 kilogram, 2 meters per second was the speed. Okay, and it hit something that was going 0 meters per second and weighed 2 kilograms. So velocity was 0 meters per second, and that weighed 2 kilograms. Alright, afterwards, object 1, the cue ball, is 1 kilogram, and it's going 0 meters per second because it was at rest. So 0 meters per second, and it weighs 1 kilogram. Alright, object 2, we don't know how fast it's going, but we do know that it weighs 2 kilograms. So the mass is 2 kilograms, question mark, meters per second. We don't know how fast this is going. Okay, plug in values. Since I have an after of object 1 and object 2, I have to have the full equations, the m1, m2, on both sides. Alright, so m1 v1 plus m2 v2, and this is the before side, equals m1 v1 plus m2 v2. This is the after side. Alright, we'll plug it all in. So the mass and the velocity of the first object were 1 kilogram. This is the cue ball times 2 meters per second, plus mass of the second object was 2 kilograms, and it was going 0 meters per second. So we know what that's going to be already. So 2 kilograms times 0 meters per second equals, we've got afterwards, so the other side is the after side. The mass of the first object is 1 kilogram, okay, times 0 meters per second. The cue ball was at rest afterwards. And then plus, finally, the object 2 has a mass of 2 kilograms, but it's going at, we don't know how many meters per second, so I'm just going to write V2. And make sure you write that multiplication sign in there. If you write an addition sign there, you will get the incorrect answer. Because in the end, since it's multiplication, what are you going to have to do? Divide, exactly. Okay, 1 kilogram times 2 meters per second, I'm going to get 2 kilogram meters per second. Okay, 2 kilograms times 0, we don't even need to write anything there. That's going to be nothing. Okay, then 1 times 0 on the other side, we don't need to write anything there. That's going to be nothing. Then we have 2 kilograms times V2, so 2 kilograms times V2. We can't do anything with this yet. Okay, next we're going to solve it. So I'll rewrite everything up there. So 2 kilograms times meters per second, 2 kilogram meters per second equals 2 kilograms times V2, 2 kilograms times V2. Alright, in order to find out what my velocity is, get that alone, we need to get rid of this 2 kilograms, so we'll divide both sides by 2 kilograms divided by 2 kilograms. Okay, kilograms cancel out on both sides. The 2's will cancel out over here, and then 2 divided by 2 is what? 1. So I'm going to have 1, and the only units left here are meters per second equals, and then V2 is my final velocity. So my answer with units will be 1 meter, or V2 equals 1 meter per second.